Hello. Under Unit 4 of Dbms, we are going to discuss about the transaction management, concurrency control, and recovery system. The collection of operations that form a single logical unit which is intended for a particular work is called as a transaction. A unit of work is called transaction. Whenever a transaction is being performed, it should obey ACID properties. A stands for atomicity, C for consistency, I for isolation, and D for durability. The transaction may be in any one of these states. One, active state; another, partially committed state; the third one is failed state, aborted state, and finally the committed state. The committed state is the state which is completed, the work is completed and it is committed, done. That's called as a committed state. The transaction should reduce the waiting time and the average response time should be less. And the transaction should follow multi-programming concepts to speed up the work and concurrency control policies. The transactions need to follow schedules. The scheduling is nothing but which transaction should do first, which next is being ordered by scheduling. In scheduling, you are having non-recoverable scheduling, recoverable scheduling, and cascadeless scheduling. When multiple transactions are going on, the concurrent transactions are going on, one transaction should not hamper or disrupt the data of another transaction. For that, we go with the locking system. You are having two-phase locking system. You are having different types of locks: shared locks, exclusive lock. In shared lock concept, when one transaction is working with the data item, the same data item can be tampered or can be read by another transaction. That is a shared lock. Exclusive lock. And coming to this, when one transaction is working with the data item, no other transaction can touch that data, which is called an exclusive lock. And you are having the concept of timestamps, read timestamp, write timestamp, based on which the transactions takes place. Also, you are having a concept called multi-version snapshot isolation concepts, with which when concurrent transactions are going on, one transaction will finish its work and the other transaction will take care of the data. Even in this, you will be maintaining multiple versions, and all this is meant for consistency of data. Improper sharing of resources or the data items to various transactions leads to deadlock. In deadlock state, the system gets hanged up, for which there are some measures which are called deadlock prevention, which is done by ordering the data items; deadlock detection, which is done with the help of wait for graph; and deadlock recovery. In deadlock recovery, minimum cost is being estimated and that transaction is being removed or killed. Whether the transaction happened successfully or not is being judged with a validation based protocol. You are having the read phase, validation phase, and then write phase. Unless and until the data is validated, it is not recorded into the disk. This concept is done with the help of validation based protocols. Failure and recovery. The failure classifications are transaction failure, logical errors, system crash, and disk failure. Recovery techniques are there to recover the failed data. You are having a log based records with which you can recover the data modifications, that is the deferred modification technique and immediate modification techniques with which you can recover the data. There is a concept called checkpointing with which you can recover the data. Thank you.